Go ahead.
Hi, my name is David. I'm in a dual degree with robotics and automation and electronics computer engineering technology. Today I have my open house project, which is a score bot that I'm controlling with this little power glove, if you will. I just got a work glove from Home Depot and super glued an accelerometer to it, as well as a little push button to detect my hand closing and opening for the gripper. So when I flip this enable switch here, by the way, this is the Zyba board. This has a Zinc 7000 microprocessor chip on it. This is the entire brains of this project. So it is reading the accelerometer, reading the data from that, and outputting it to these GPIO pins, which is then controlling, well then it's going to an H-bridge, which is controlling the motor function.
Okay.
So when I flip the accelerometer on, the robot follows hand movement.
Oh, neat.
Up, down, side, go down, I'll pick up this cube, move this around, up, down, move it, up, do it all again.
Great. Now, if you move the glove too slow, will it detect it? Like if you move really, really slow, will it keep up?
If I just move it like side to side like this, it tends to not.
Right.
It's morally based on the tilt.
The tilt.
So if I tilt my hand side to side, that's
Right.
more effective than if I
Right.
tilt it up and down.
I see.
I discovered that pretty quickly.
Yeah. So this would be good for trying to defuse a bomb or something remotely,
I was
yeah.
having a conversation with a couple people about. I'm like, this could probably be used for hazardous material cleanup or something like that. Something that you couldn't actually program a robot to do in that amount of time. So,
Right. Good.
like a factory spill or a chemical leak or something like that.
Right. So your program. Let's take a look at some of your more of your programming. So.
Got a lot of code here.
A lot of code.
So I'm actually using two cores. There's two cores on the Zinc chip, and I'm using both of them.
Okay.
The first core is using the normal axis control. So the first 5 axes are being controlled, as well as reading the accelerometer is being done by the first processor. So there's all my code for that. I also have a manual jog kind of programmed into this.
Okay.
That way I can like flip a switch and then start pushing buttons and different axes will move. So I have that programmed into there. This is where it reads the accelerometer. And then on my second core is just reading the gripper. It's just controlling the gripper. Excuse me.
Okay.
So I have like a separate GPIO for the gripper motors. I partially did this on a separate core because, well, one because I wanted to do this for my final project for digital circuits, or for digital systems.
Mm-hmm.
So, and dual processing was one of the topics on that. So I'm like, well, I'll get this working for that.
Great.
Also, this hangs up the entire while of the gripper opening and closing. Because I don't have any like current sensing or like limit sensing circuit on my circuit board, I tried to get something working and I didn't quite get it to work. So what I did was this timer. I couldn't get a private timer to work, else that would have been much more efficient. Instead, I created a for loop. So it senses when the button is closed, and it turns the motor on to close the gripper. And this for loop waits. It goes through that number of iterations. That's like a huge number right there.
Yeah.
That's in hexadecimal.
Yeah.
And then the time it takes for the processor to go through that is the normal time it takes for the gripper to close.
Okay.
And so by the time that is done, it should be closed and turns the motor off.
Okay.
The same thing happens here when I open the motor. It turns on the motor to open the gripper. When I open the button, it turns on the motor to open the gripper for that amount of time and then turns it off. If I had just left, because my problem is that I only have a button it's either on or off. It's either open or closed. I can't have the motor like constantly turning all the time, or also have a huge current draw, and I'm going to blow up one of those chips.
Exactly. Yeah.
So I had to come up with a weird way to.
Well, a timer is one way to do it. That's fine. Yep. Yeah. So you had to kind of experimentally get this value.
Basically, I started with it's a 325 megahertz clock. So I started with 325 million, and that wasn't enough, so I doubled it, and then I just kept changing numbers from there.
Okay. Hey, that's one way to do it. Looks great.
Yeah.
Okay. Thanks, Dave. Good job.